we're going to be talking about controllers. Now let's find the controllers in our little map of where things live. Let's go to our app developers. Whoops, my bad, sorry. Yes, sharing screen. Screen one, there we go. All right, so I'm in Confluence, app developers, project architecture. This is going to live down here in the interface adapters. If you dive into here, you'll see that I have not written anything other than a to-do, but gives you an idea of where this lives in the hierarchy of our dependency chart. It's getting towards the outside. This is living out there. It's in the same layer as our presentation managers. And it's kind of like the bearing. I'm a mechanical engineer. My background's mechanical engineering. So I think about mechanics and a bearing, like a shaft turning inside of an engine. There's this whole interface where those two things come together, and it's very complicated and a lot of moving parts. But that's what I think about this layer. So we're going to be adapting our input from our user to the domain, to the inside, to our use cases and our entities. So if I come back out here to the architecture, you'll see here we are. Here is where a controller lives, right here. So we're in the green layer. We're in that interface adapter layer. And notice that this receives a controller. At its very definition, its very heart, it receives input from the user. If you guys know about model view controller paradigms, this is kind of the same thing. Controllers take input. Basic, that's it. They take input. Now the question is, what is the device that's giving them input? So the reason why we split controllers out is because we expect to use multiple input devices. Easy one is a mouse. We all can think about mouse uses. Click, drag, left click, right click, roll, those kind of things. Those are mouse. That is input coming from a user. We also can use touch, pinch gesture to zoom, one finger to drag, two fingers to pan, that kind of stuff. That is another input from a user. Keyboard is another input type. Keys, hotkeys. If you press the arrow key, maybe we orbit the view. If you hold down the left arrow key, we orbit or something like that, right? That is input. We want to separate the idea of the input, the controller, from the use case. So another way to think about that is, let's just take a simple example of, I want to use one finger to orbit the scene. So I'm going to touch, I'm going to drag my finger, and it's going to spin the model around, spin our world around. Or I'm going to left click and drag, and that's going to also do the same thing and spin that world around. Or I know you guys don't have much experience with ZSpace, but in ZSpace we use a stylus. If you guys think about HMDs or gamepads, that is an input device. So with this tool, I want to also click on one of these buttons and drag and spin the world around. Well, isolate those two things. There's two things we're talking about. One is the math about dragging and spinning the world around. That belongs in the use case. We want all of these input devices to use as much of the same code as we can. So what does that look like? That's typically a ray coming in. It's picking on something, and then it's spinning the world around that pick is what we typically do. Well, that ray could come from my mouse pointer. It could come from my finger touching the screen, or it could come from a 3D stylus to spin the world around too. So that's the separation we're doing. When we get into controllers, you're going to see keywords like touch, like mouse, like key, on key down, on key up, or on mouse down, on mouse up. That is your identifier that is a controller. We are talking about a controller at that point. All right, any questions on that? Okay. Oh yeah, go ahead.
So simply input a controller is basically any sort of input from a user.
Yeah.
So the input, i.e., going through React. So for example, if a user
Good point.
has an on-click command via React,
Yep.
the controller
Yep.
compiles that. Sorry, I'm just trying. I'm
Yep.
taking notes right now.
Good point.
Put it as
Yeah.
lines that you can.
Good point on React. I forgot to mention this. We often do not see React connecting to a controller. React kind of takes care of that by itself. A lot of the controller aspects of what we do is already controlled by React. So things like button hover state. So when you hover over a button, React takes care of a lot of that stuff of like changing the button state. When you press the button state, the view of that button changes. All right. So a lot of times, and you guys have been mostly working in React, React skips the controller layer and goes right to use cases primarily. Where we will see controllers coming in a lot is when we get into the 3D scene. When we start clicking and dragging and moving on the scene itself, because we have to handle all those states. You guys, I don't know if you've seen some of the work going across about the hovered scene object or the pressed scene object. We're writing, Robbie's in the middle of writing those controllers. Essentially, when you press on a mesh, in this app, we want to treat that like a button, right? But that means we don't have React doing all these mesh states for us. So we have to write these controllers that take a touch input and turn that into a press event, or highlight that controller and stuff, or that mesh and stuff like that. So this really becomes important. Controllers really become important when you start seeing Babylon in the 3D scene.
So, okay, I guess I'll ask more questions when
Yeah.
it's on there, because I'm just wondering how does the controller know? Like,
Yeah.
and for example, in the 3D scene, does Babylon have its own version of like on click? I'm just throwing one out there.
Yeah.
Or hover.
Yes.
Or something of that nature.
Right. Yeah. Okay. Let's get into it. I think this will answer your questions. So we've got whoops, I didn't mean to unshare. Let me go back to sharing. All right. So let's get into it. Let's just pull one up. So I'm in the Bitbucket here. Or I'm sorry, not Bitbucket. I'm in into the Hotspot app. I'm going to close everything and I'm going to pull up a card real quick. And what we're going to do is we're going to do this mouse press on a scene object. So you can see right away we got the word mouse in there. Indicator, this is a controller. We're dealing with a mouse press. We're probably going to write the same thing with a touch press at some point. But right now we're talking about mouse press on a scene object. All right, when the primary mouse button is pressed, it should send a ray to this press on scene object, try press use case. So we already have a use case ready to receive this input. We have to send it a parametric ray. A ray, just so we all know what we're talking about. This is a 3D scene now. We're no longer in 2D. We are casting a parametric line into our 3D world. And that line it's going to be coming directly from under the mouse. So when we press the mouse, we've got all this math all figured out, but essentially you could form a ray that would be the same as that ray going from your eye through the mouse pointer into the scene as a laser, right? And we're trying to we don't do anything else with that. We start with that. We're just casting a ray into the scene, and we've got the math for that already figured out. All right? While pressed, so we're doing this mouse press, if the mouse moves, we call this function already available on the use case called update press, and we're still going to be passing in our mouse ray. If a different button is pressed while the primary button is pressed, it should call this unpress function. And when the primary mouse button is unpressed, it should call unpress on the use case. So the key here is we're just taking mouse input, figuring out how that turns into array, and monitoring these mouse-specific events like move, like unpress, and other buttons being pressed. Notice those are all specific to the mouse. And we are sending messages to a use case saying, hey, we've got an unpress. Hey, we've got a move. Hey, we've got another button, or cancel or unpress. We're doing that, right? The key here is you can imagine we could do the same buttons with a stylus. The use case doesn't care if the ray is coming from a mouse, or if it's coming from a 3D stylus, or if it's coming from a touch. The use case doesn't care. All it's asking for is a ray. So the controller is taking mouse-specific inputs and converting them, adapting them to match up with the use case, and then calling appropriate functions on the use case. All right? So that's our goal. The end thing that this is going to do is we're going to treat meshes at certain moments inside the app, and the use case and the entities and the presentation manager will figure out these specific rules. We're going to treat meshes like a button. So when you press on a mesh, it's going to change its appearance slightly, just like a button does. And if you drag off that mesh, that appearance should go back. If you lift off that mesh, if you unpress, that button should go back. If you press a different button while pressing, that should be unpressed, essentially. We're not registering clicks. We're just handling this pressed state. All right. Let's go ahead and take a look at this use case real quick to see what we're going to get into. This press on scene object. This is a use case I wrote a couple days ago. So we're going to jump into here. Controllers almost always talk to a use case. So what do we got? Press on scene object. All right, this is the use case we're gonna tie into. You can see, I'm gonna hide the private. It's got three functions that are exposed. Try press. So we're gonna try to press. Again, when we click with our mouse, we don't even know if we've hit anything. We're just sending an array into the scene, and we're saying, hey, try to press on something. I don't know if you can hit anything or not, but go for it. So we call try press, and we send in a pick ray. Then the use case does its magic here, whatever. The controller doesn't really care what the use case does. If the mouse is moved, we want to update. We may still be colliding with that same object, and if we are, good. You get some jitter when you press the mouse anyways. People move their mouse, they move when they press. So the rules are, if it's still colliding as you move across, we're good. Don't do anything different. But if you slide off, if you are holding down press and you slide off the original picked object, we unpress that guy. We don't need to press him anymore. And then finally, we do this unpress. This is what we call when the mouse button is lifted. So that's what we got to do. We got to wire up a controller that takes in mouse inputs and calls these three functions appropriately. Easy peasy. Let's do it. So we're going to jump over here. This is an interface adapter. We have a controllers folder. We tend to bust our controllers into input types. So you can see we've got mouse, stylus, and touch already. Stylus is the Z-space that we haven't really gotten into, but we'll be seeing more of that as we get down to this thing. It's a 3D. You can think about an HMD when you're wearing the goggles and you've got your 3D styluses. That would be the same thing. Let's get into here. You can see there's already a bunch of mouse controllers in here. We got mouse orbit, mouse pan. So these are great places to look on what happens. Let's just take one of these. Mouse pan might be a good one. I know this one's going to have some of the similarities. We're going to get a press, we're going to get a drag, and we're going to get an unpress. So let's look at this mouse pan real quick, just to kind of get an idea of what controllers are made of. This gets into your question, Emil. First thing to notice, this class, mouse pan, implements this type, mouse controller. So this is it's going to set us up with some possible functions we might use. And let me just pop this open. Let's go to definition of mouse controller. This is it's in a package, but you can see these are the events we can use: on click, on up, Or on click, on down, on up, on move, and on wheel. These are our mouse events that we can, notice they're all optional as well. So our controllers can pick, what do we want to listen to, all right? And then we get this mouse input event. And this is our version of the interface of an event. You'll see we boil it out a few ways just to make life a little bit easier. We get the vector, the pixel position. We get our mouse button. And we also go ahead and send the native mouse event back out too. And that allows you to use that if you want. Yeah, go ahead. Oh, you're muted.
Sorry about that.
Yeah.
So, mouse input event. I guess what I'm trying to ask is, like, this is brilliant. It all makes sense to me, right?
Yep.
But I guess I'm going to ask a simpler question. So, is the interface of mouse input event, is that constantly updating and giving updated position button number?
Yeah. Good call. So what's happening is these events will be called. So while your mouse, every time the mouse moves, the underlying system, we haven't quite got to the deeper system yet. This is going to if you've implemented. So I'm going to come over here to mouse pan. We have implemented on move. So every time the mouse moves, this is going to be called with an input event, with an E, an input event. That input event will give you the button number that's pressed, or what buttons are pressed. It will give you the 2D vector, the pixel position, and it will also return the native mouse handler event, just in case you still need to use that, because we don't always know what you're going to use. But most of the time, you just need a button and a position is really what we've found. But we still include that event just in case. All right, let's get into the deeper system real quick. First thing, so we've noticed that this mouse pan, this is what pans the 3D scene around when you press. It implements the mouse controller. So we are a mouse controller. There's also a touch controller and there's a stylus controller. Those are three different controllers. They have different things. Touch, you can imagine, has different callbacks. Now down here in the constructor, notice this. We register ourselves as a controller with an entity called mouse input. This is where the magic happens. So, mouse input, the actual nuts and bolts of when is a mouse actually clicking? Is it on the scene? Is it on this? We don't care about that. That's all being handled in a centralized system. And there's a controller out there. There's a deeper controller that's taking care of. All we care about in our controller is we register with that. And from then on out, that thing will notify us every time it picks up a mouse down, on down. It'll notify us. That's all we have to worry about. We don't have to worry about adding event listeners to a canvas or an HTML element or anything like that. Yeah, go ahead.
Sorry, I was muted. Yeah. So is this an opportunity, like if we're writing test-driven development, not that we would be on this, would this be kind of like when we would use a spy or an observer pattern?
Yeah.
This?
Yes, this is exactly why we're doing this, is because of test driven. What this does is by separating, if you guys remember, let's see if I can find, let me see if I find actually where we hook up inputs. All right. Maybe not. Scene rare. There's a deeper piece of code. So essentially, somewhere in our code base, when we make our canvas that we're rendering we render our 3D scene, our Babylon scene into a canvas. When that starts, we also connect up a bunch of those, your typical HTML event listeners, canvas event listeners, all that stuff. We also, our canvas can come and go. So it gets deleted, it can go, things happen. But that is the moment that we actually connect it to that entity. Our controllers, the controllers we're worried about, we don't want to get bogged down in the details of what's the canvas, what's the actual element, because that makes testing difficult. All this controller cares about is, hey, if I get a mouse click, I need to do this. And now I can focus my tests on just that single responsibility. On press, do I call this guy? On up, do I call that guy? That's all we're doing with these things. All right? Okay, so let's start building. So we're going to come into here. Let's look at our here we go, right here. Okay, so this is called mouse press on scene object. Let's start with that. So I'm going to go ahead and jump into my thing here. Mouse press on scene object. TS. And right away, what do we do? Good developers. We're craftsmen. Test TS. All right. Let's go ahead and get this guy to not be a compiler error. So let's do export. Whoops. What's going on here? We're going to export a class called this. It's going to implement. All right. Quick note, implement versus extends. Subtle details. You guys not familiar with that, you can look it up on the, you can go look on, this is TypeScript, this is object-oriented TypeScript stuff. Implements means we're looking at an interface. So we are promising to fulfill an interface. Extends is more like dependencies. We are inheriting a lower base class. So quick note on that. Not that it matters a ton, just there's a little bit of difference between implements and extending. We are just extending, we're implementing an interface. And that interface, let me look it up real quick, is called mouse controller. Let me bring that in. I'm going to import that. That is imported. Notice we are bringing that in from our app package. That is something that's not in this package. It's in our NPM app package. Vivette owns that. We manage that package. It's our package. But it's such a common feature. We use it in all of our apps. All right. Now, let's see. What else? Okay, so let's go ahead. And now we've got at least a class running. Let's get our tests over here. Let's get our tests going. So let's do function. Function. Make test rig, our usual approach. All right, and I know we're gonna need our entities. We always need our entities. So let's do our constant entities is gonna be make entity context. So we bring that in, and then we know we're gonna need entities in here. So let's go ahead and just build our constructor, and it is going to bring in our entities, entity context. And let's go ahead and get that. So we have our constant controller equals new mouse press on scene object entities. All right. So let's go ahead and return these two. Now I'm going to spread the entities. And we're going to, oh, I spelled controller wrong. We'll just F2 this. Controller. And then, no, we don't want to do that. We want this to come out. Now, we want export. No, we're going to do our describe block. Describe mouse press on scene object. All right. Now, all right, first thing. I know in my constructor, like I showed you guys over here in the pan, first thing we need to do is I want to make sure that we don't forget to register ourselves. Make sure this piece of code's there, because this is an easy thing to do. Essentially, this entity is going to register itself, and then it just starts working. And if you don't get inputs, if you're like clicking, there's a lot of reasons why the clicks won't work. But what you don't want it to be is a dumb mistake like you forgot to register, because that's just annoying. So let's go ahead and just check and make sure we make our register controller. So here's a good spot for a spy. So it registers as a controller with the mouse input entity. All right, so first off, this is a function that happens in the constructor. So we kind of have to circle back, and we have to do this new call again, because I want to set up a spy before I call new. So I'm gonna do a little funky business here. I'm gonna just return entities as itself, and I'm gonna do this now. I'm gonna do constant. Let's get our test rig, make test rig. There's a couple ways we could have done this, but we're just gonna take entities out of here. And I'm going to grab my entities dot what was that? Mouse input. And we're going to do a, let's see, what's the SPI? We're going to do, I think it's called register controller. Okay, I'm just going to throw that there for now. We're going to do a constant SPI is going to equal jest.spy on, and then I'm going to grab this, like this, X, and we'll just throw this in here, and we'll put this in as the string, because that's how they want the format. All right, so this hooks up our SPI. Now, we're going to make our own controller here, down here, and we expect that the SPI to be called with our controller. All right, so we're just checking on construction to make sure that we register controller on the mouse input. All right, let's get this test going. Move this out of the way. All right, npm test. Let me just grab this name so we don't have to test everything. Copy. And this is probably going to fail because we are not doing it. So let's see what happens. All right, we did. We failed. All right, so now we come over here. We do entities dot mouse input dot register controller this. All right, and we're able to call this because we are implementing this interface. So we're injecting ourselves in as kind of like an observer. It's an observer pattern, just like our other entities. And we're just going to expect this mouse input is going to now start to notify us whenever mouse events happen on the 3D world, on the space. So there we go. All right, so that's passing. All right, let's look at our requirements again. Okay, when the mouse button is pressed, it should send array into this use case. All right, a couple things here. We got a press we got to be watching for, and we need this use case. Let's go ahead and get this use case set up. So let's come back over here. We're going to do this trick where we exposed the use case in the class, and then we override it, or we spy on it maybe in our test case, and we just check for the calls is what we're going to do. So we're going to do, what's this thing called? Press on scene object UC. I'm going to call it that. Let me do this real quick. We're going to do this UC, and it's going to be of type this. And let me just lowercase that. Put this in here. Do we bring it in? We need to import it. There we go. We're bringing it in from our use cases, so that's good. Now, this dot press on scene object UC is going to equal make press on. No, this is a class. New press on scene object, and we pass in the entities. Okay, so. All right, why is this not happy? Okay, it's got no properties in common. So we got to put in one of our things. So again, I'm going to pop this and let's go to the definition of this. We're going to go ahead and just put in, we know we're going to do an on down, an on press event. So let's go ahead and get this in. It's complaining because we haven't implemented anything that is similar. So let's go ahead and get this going and set this up. So we're going to wire in our on down mouse events. We're going to use an arrow function. This should return a void, and it goes to this. And we need an equal at the end of this, and we need to import this guy. All right, we're getting getting the compiler to work. All right, now we're happy again. Okay, so now so notice what we've done is this controller references a use case, which is good. You know, we're in the green layer pointing inward, so we can be dependent on use cases. So we can point down into our onion of dependencies. And we've instantiated this. This particular use case is a class use case. That's not a functional use case. And that's because you'll see this often, especially with mouse input type stuff. Unless it's a click, a lot of the mouse and these kind of inputs are time-based, right? Pressing and releasing takes moments of time. It's not just, boom, you're not just done. And so you'll see, so that means usually you need to hold some state. You need to know, okay, what did I press on? There's reasons, but because it's primarily happening over several frames of iterations. And so that's why this is a class-based use case. All right, so on down. All right, let's see. Let's get back to our test real quick. Nope, not that one. Let's look at our... Okay, on primary mouse button down, a primary mouse button is pressed. It should send array into this try press use case. All right, we can check for that. Let's write a test. So, okay, it sends a ray into the try press when the mouse is pressed. All right. All right. Let's get into this. So let's go ahead and grab our test rig. And we're going to need our controller this time. And what I know is this. We're going to do controller. We're going to trigger this on down. We're going to fake it. We're not going to actually like do a mouse press. We don't have to do any of that. Because we've boiled this thing down into just worrying about what it needs to do, we're just going to trigger the events like a mouse. We assume that the mouse input system is all tested and it's going to actually trigger the events. So we're just going to call on down. So we're going to do controller on down. And what does it need? It needs this mouse input event. So let's see. We need to make a mouse input event. If I remember right, sometimes I have to look back. Let's look at our other tests and see how we make a mouse input event for these guys. I think... All right, looks like we just do it. All right, let's grab this. I'm just going to copy this over. And we'll just make a mouse input event. All right, let's do this. And I'm going to import this. And I'm going to import this vector2. This comes from our value objects. Let me talk about vector2s real quick. Vector2s. It's a vector. If you guys don't know vectors, give me a shout, but it's a 2D vector. So this is our pixel coordinates. You'll notice, here's a key. If we're not careful, let me do this wrong. And I import a vector2. I have two options. I have an @Babylon vector. And I have a vivid apps lib value object. If I'm not careful, I will import a vector2 from Babylon. All right, let me pull this up real quick. Babylon, remember, Babylon is a framework. So it's in the blue layer, right? Oh, I don't want that button. What am I doing? Stop.